So making the bio-vital compost, you want to get yourself a mesh. This is just a fancy wire. You can use weld mesh. You don't want to use wire that's too thin because it will collapse under the weight. Even this stuff is on the thinner side. Ideally you want 6mm weld mesh, that's perfect, but this will do the job. This is farm lock fencing. So you want it to be 1.2 meters high, or 4 foot in the Imperial. And the length, as you can see, it's joined up in a ring here. But when this is laid out on the ground, it's 6 meters long. So then it's brought around and just overlap, just to, so it's just slightly overlap, just to hook it together to hold it. You'll be undoing this a number of times because the compost gets turned every 8 days for 8 weeks. So you'll be undoing it, I think it's 6 or 7 times. So that's the mesh. And the reason you want it to be mesh, nice and open, is because the air will go in. The ideal size for compost, if you remember your geometry, you want the greatest amount of internal area for the least amount of external surface area. So the perfect size, of course, is a ball, a sphere, but of course you can't have that when you're building compost. So this is why we use a mesh, because having the compost built up and then sort of mounded over is the closest thing we can get to a ball. So the most interior mass to the least exterior surface area. And of course it lets the air in as well. So that's the ring there. This is where we're building it in. And then as you turn the compost, it will reduce in size, but it will increase in weight because you're adding more water and things like that. So as we turn it, and you'll see this in subsequent videos, we'll make this overlap a little more and a little more and a little more until eventually it's a little smaller in diameter. But it'll be weighs about, we weighed on a weigh bridge about 850 kilograms is what all this compost, almost a ton, is what it weighs when it's finished. So the other thing we'll talk about just at the moment as well is the ratios of remember the 3 main ingredients. There's the browns, the greens, and the high nitrogen. So the browns are your straw and your wood chips, right? Straw, that's wheat straw, wood chips or woody material, and pea straw. They're our browns today. You want 3 parts of your brown material. You want 2 parts of the greens, which are we've got the lucerne chaff, we've got good quality oat hay, and we've got garden prunings. That's the green. So you want 2 parts. So 3 parts your high carbon browns, so straw and wood chips. 2 parts of your green material, so hay, prunings, lucerne chaff, that sort of thing. And then you want 1 part, which is your high nitrogen, which is your manure. So we've got nice fresh cow with a bit of sheep manure mixed in here. We've got horse manure. We've got some more sheep manure in the bags, and we're going to have some chicken manure from the yard waste from the chicken tractor. So 3, 2, 1. 3 parts high carbon brown material, straw and wood chips. 2 parts greens, which is hay, garden prunings, etc., and 1 part nitrogen, high nitrogen, which is your manures. So that's the ratio. So we'll get started now, and we'll get started on this straw. And we're going to be adding water all the time, well, virtually constantly. So see how this is from the centre of the hay roll. It's very dense, right? You're going to break that up. It's got to be fluffy. Sometimes you get straw in compressed bales. That's really not a good way to go because it's had all the air and all the cavities forced out of it. And so the microbes have got nowhere to go, basically. You want aerobic microorganisms, which means you need air. So that's 1 measure. I need to do 11 more after this.